Greetings, everyone. I'm Captain Pankaj, with 17 years of experience trading pilots all across the globe. I am here to guide you through the intricacies of the DGCA syllabus.
Right off the bat, I want you to internalize this. Discipline is the bridge between a student pilot and a safe commander. Keep that in the back of your mind today. So, welcome to our ground school session. Let's look at the boards and really dive into the technicalities of what makes a true professional aviator.
Okay, here's our roadmap for this explainer. We are operating on a strict zero-skip policy today. So we're going to cover regulations and operator certificates, flight duty time limitations, aircraft performance and equipment, meteorological hazards, and finally, in-flight emergencies. All right, let's jump right into Section 1, Regulations, AOC, and Documentation. We absolutely have to lay down these foundational ICAO frameworks before we even think about stepping onto the flight deck. So take a look at the structure of ICAO Annex 6, which is all about the operation of aircraft. It's basically split into three parts, right? Part 1 is for international commercial air transport, Part 2 handles international general aviation, and Part 3 is for international helicopter operations. Now, pay close attention to that high-visibility amber box. This is a massive exam tip memory aid for you. Think 169 and 86. General aviation applicability started in September 1969, and helicopters followed in November 1986. You really need to memorize those exact dates because, trust me, examiners absolutely love testing your precision here. Moving on, if we trace the Air Operator Certificate, or AOC, pipeline, you'll see an airline can't just wake up one day and start selling tickets. They have to prove their adequacy in organization, training, flight ops, ground handling, the whole shebang, including maintenance. But the real kicker here is in that blue regulatory block, continuous state surveillance. The validity of an AOC totally depends on the operator maintaining those initial certification standards, and doing so under the constant watchful eye of the state. It's not just a one-and-done test pass, it is a permanent regulatory commitment.
Now let's talk about some strict limitations, which you'll see highlighted in red. First up is unauthorized carriage. This literally means an operator has to take every reasonable measure to ensure nobody, and no undocumented cargo, hides on board. It's a zero-tolerance policy for stowaways. Second is the red critical safety limitation regarding portable electronic devices, or PEDs. You simply cannot permit the use of any device that might adversely affect the airplane's systems. And why does this matter? Well, it's because of the severe threat of electromagnetic interference with your nav and comms equipment, which is especially dangerous during those highly critical phases of flight.
Okay, let's shift gears to Section 2, Flight Duty Time Limitations, or FDTL. Listen, pilot fatigue management isn't just some HR policy. It is absolutely crucial for operational safety and is heavily tested on your exams. The really important takeaway here is understanding exactly how maximum hours are applied. So for a standard 2-pilot op, your maximum flight duty period could be 13 hours if you're only doing 1 or 2 landings. But that number drops significantly if your ops start creeping into nighttime. Now, take a look at the bottom half regarding augmented crews. By bringing along an extra pilot, crew members can take designated in-flight rest. This is what allows us to safely and legally extend our maximum flight duty period.
Let's make sure we lock in this next DGCA exam tip. The rule is actually pretty simple. Better rest facility equals longer FDP allowed. A bunk, which is a proper lie-flat bed, always gets you the highest flight duty period. A step down from that is an isolated rest seat. And down at the bottom is a basic rest seat, which gives you the absolute minimum extension. You need to pay close attention to this strict limitation. A basic rest seat is totally restricted, as in not available, or NA, for 4 crew or ultra-long-range operations.
Moving right along to Section 3, Aircraft Performance and Equipment. We're getting into the technical heart of this explainer now, determining if an aircraft is actually legally fit to fly.
Let's break down dispatch reliability by tracing the path from the manufacturer all the way to you, the pilot in command. First, the manufacturer drafts the Master Minimum Equipment List, the MEML. The operator then takes that baseline and customizes it for their specific operations manual, which you can see in that green operational path. But check out the red regulatory application block. An operator's MEL can never ever be less restrictive than the manufacturer's MEML. So if a piece of equipment fails while you're sitting at the gate, the MEL is literally the first document you open to make your go or no-go decision.
Now, how does the MEL contrast with the Aeroplane Flight Manual, or AFM? Well, the AFM contains the certified performance data established by the state of design, which factors in variables like mass, runway slope, elevation, temperature, and wind. I want you to read that red limitation box very carefully. You must operate strictly within AFM limitations. Guys, these are absolute legal boundaries. They aren't friendly suggestions. You simply cannot negotiate with physics, and the DGCA expects you to know this intimately.
Let's see how this concept of limitations builds into noise abatement. The tactical blue concept here shows us modifying thrust to minimize noise exposure for the population down below. But look closely at the red warning limit. You shall not execute these procedures below a height of 240 meters, that's 800 feet, above aerodrome elevation. And that high visibility amber exam tip, always remember that safety supersedes noise. The 15-5 dry rule tells us that noise abatement is completely canceled if your crosswind is over 15 knots, your tailwind is over 5 knots, or if the runway is anything but clear and dry.
When it comes to the clean aircraft concept, it is literally zero tolerance. On the left side, notice how we use red, heated de-icing fluid to strip away existing frozen contamination from a dirty surface. Then on the right, we use green, unheated anti-icing fluid to prevent new ice from accumulating on a surface that is already clean. Look at that red limitation at the bottom. It's uncompromising. Even a microscopic frost accumulation of just 0.40 millimeters is enough to cause severe lift loss. Bottom line, you do not take off unless you are 100% certain those wings are completely clean.
Let's push forward into Section 4, Meteorological and Runway Hazards. We're talking about invisible atmospheric killers and severely degraded runway physics here.
The microburst is a truly lethal atmospheric phenomenon. Our tactical blue box defines it simply as intense local downdrafts. But take a hard look at the amber box. This is the infamous microburst trap. As you first enter it, you get slammed with a sudden headwind. Now, this causes an artificial temporary surge in your performance and airspeed, which dangerously masks the massive downdraft and tailwind that follow instantly after. If you ever get caught in this, you must firmly dictate the green standard operating procedure recovery steps: full power, pitch up to the absolute stick shaker limits, and absolutely do not touch your gear or flap configuration.
Right, let's analyze wake turbulence. These are basically invisible, horizontal tornadoes that spread out from the rear of the wings and sink down about 1,000 feet below the flight path. Here is a massive amber tip for your exams. A heavy, clean, slow configuration is what produces the absolute maximum wake turbulence. And, tactically speaking, the deadliest weather scenario you can face is a light, quartering tailwind while landing behind a large aircraft. Why? Because that specific wind keeps the upwind vortex parked right on your runway centerline. To combat this, we use incredibly exact, minute-based longitudinal separations. You've got to look closely at these amber boxes because examiners love setting traps here. Say you're in an arriving light aircraft landing behind a super heavy A380. The strict wait time is 4 minutes. But if that same light aircraft is departing on the same runway behind a medium aircraft, the requirement is only 2 minutes. You really need to memorize this matrix completely. This time separation is what allows those lethal vortices to safely dissipate.
Once you do safely cross the threshold, you've still got to deal with runway contamination. And in aviation, precise millimeters matter. A damp runway has moisture on it, but it isn't shiny. A wet runway is shiny, meaning it's covered with water that is less than or equal to 3 millimeters deep. Now, a contaminated runway means you've got standing water greater than 3 millimeters. You need to apply this high-visibility amber exam rule. If the weather reports wet conditions at your ETA, the landing distance available must be at least 115% of your required dry landing distance.
So, why is that 115% rule so critical? In a word, hydroplaning. The blue concept box here describes dynamic hydroplaning, where high speeds and standing water physically lift your tires completely off the runway, which totally wipes out your directional control and braking action. Viscous hydroplaning is a bit different. It barely needs any moisture, just a smooth, dirty surface. So, what's your green SOP application here? It's relying on your anti-skid braking systems. They prevent wheel lockup, letting you apply aggressive brake input safely so you can brake right through that layer of water.
All right, we are entering our final module, Section 5, Managing In-Flight Emergencies. This section demands total 100% memorization of fire classifications and pressurization protocols.
Let's start with the fundamental physics of fire. It requires a chemical chain reaction between oxygen, heat, and fuel. We call this the fire triangle. We systematically break down the classifications in these green operational blocks. Class A fires involve ordinary combustibles like wood and paper. Class B covers flammable liquids and fuels. Class C is electrical equipment. And Class D involves really dangerous flammable metals like magnesium and lithium. To fight a fire successfully, you have to aggressively break that triangle by either cooling it down to remove the heat or smothering it to choke off the oxygen.
But you have to match those fire classes with the correct extinguishant, and that is a life or death decision. Look at the red limitation here. Regulatory law explicitly requires at least one Halon 1211 extinguisher to be physically located on the flight deck. It is incredibly effective for Class A, B, and C fires. Now please note the severe exam warning in the amber box. Water is strictly and only for Class A fires. Never ever use water or halon on a Class D metal fire. That requires a specialized dry powder, otherwise you are literally risking a catastrophic explosive reaction.
Finally, let's wrap up with cabin pressurization and rapid decompression. A rapid decompression happening in under 0.5 seconds is going to cause fog, flying dust, and an instant sub-zero drop in temperature. Your time of useful consciousness at 35,000 feet, it's measured in mere seconds. Therefore, this amber immediate action exam tip is completely non-negotiable. Crew oxygen goes on first. You simply cannot save your passengers if you are passed out. So, let me leave you with this provocative final question. You might have the regulations memorized, but when the warning horns suddenly sound at 35,000 feet, do you actually have the discipline to execute them? Thank you all for joining this masterclass. Stay focused and fly safe.